Hello, Mr. here. So in this video, I'm going to discuss the question in the Bengkel Pecutan 2.0 slot 1 using the answer that I get from the students. Let's start. Let's start with question number 1. The question given us differentiate rate equation. The rate here basically is referred to rate of reaction. So due to the negative sign here, so we know that the NO2 is the reactant, while for the positive side, O2 and NO, both these are product. So rate of reaction as well given 0.83 molar per minute. The question A1 asks us to write a balanced equation. So this equation is balanced, but due to the physical state of NO2 supposedly is gas, so this equation is not given the mark. Next, the question asks us to determine the rate of disappearance, at where rate of disappearance basically is without the sign 1/2. So means that we need to multiply with 2 to get the rate of disappearance. And out we get the rate of disappearance is 1.66 molar per minute. So for this question, the student will get 2/3 marks. Let's proceed to question B. The equation given is the decomposition of SO2Cl2. The question let us know it is first order reaction and the rate constant is given 2.2 exponent -5 per second. Let's say the question doesn't let us know what is the order of reaction. Based on the unit of the rate constant per second, we have the idea that the order of reaction is first order. The reaction is carried out at 593 Kelvin for 1 hour. Due to the rate constant given in the unit of second, so we will prefer to convert the hours into second, which will equal to 3600 seconds. The question asks us to calculate percentage of decomposition. Means that how many percent is decomposed, berapa peratus yang telah terurai. So means that we are going to use initial concentration minus with the concentration that left over to get the decomposition value. Okay, so since we want to involve initial concentration and the concentration left over, so means that we are going to use the integrated rate law. So when you can list down the integrated rate law correctly, we will get 1 mark. Okay, this question use A in the equation, so means that you have to let A equal to SO2Cl2, or no, you must place SO2Cl2 in the integrated rate law. So and then you just substitute the value into the formula. You will get the idea that initial concentration over the concentration left over is 1.0824/1. So that's why if you want to know how much is left over, so you will use initial, which is referred to 1/1.0824. So this is the fraction of decomposition. So but the question asks for the percentage, so you have to convert into the percent, so you will get 7.61. So basically the marks given is 1 mark for the formula and then 1 mark for the substitution at where you can get the concentration left over, and the last one you will get the marks for the percentage of decomposition. So get 3/3 for this. Okay, given the rate law, and then you are going to determine how much of the rate of reaction increase. So if you get this question, normally we try to assume initial concentration of NO2 equal to concentration Cl2, which is equal to 1. So when this is the case happen, the rate of reaction always will equal to K. Okay, so for question C1, the concentration of NO3 is triple. So that means we will put the rate equal to K. Concentration NO2 from 1 become 3. Cl2 have no changes. So maintain as 1 to the power of 2. So 1 to the power of 2, 1 times 3, 3. So will 3K. So we know that the rate of reaction will increase by factor of 3, so this one you will get 1 mark. Next, the question asks for both concentration NO2 and Cl2 are double, so we can use rate equal to concentration K, equal to K times with the concentration NO2, which is the 2, Cl2 also 2 to the power of 2. So that is why your friends over here write 2 times 4 is equal to 8, so factor of 8, another 1 mark. So for this question, your friends get 2 over 2. Okay, next continue with last part of question number 1. So in this question, they say that how the medicine in powder form works in the body. Okay, and then we need to explain in terms of how it affects the rate of reaction. So I think your friends is mentioned powder form has smaller size compared to the crystal or tablet. So if the smaller the size of the reacting particle, so that means the bigger or the greater surface area exposed. So this will increase the number of collision. Very good. And then mention also the effective collision cause the rate of reaction increase. So basically you will get 1 mark for this. But don't forget, the question is asked us how this. So this means it's refer to the powder medicine. Okay, so you supposedly add 1 more sentence. It's mentioned that powder medicine is absorbed better in the body compared to crystal or tablet medicine. Okay, so this one you will get the second mark. So for this question, you'll get 1 over 2. Okay, let's continue with question number 2. When you are given a series of thermochemical equations, so I think basically we understand that we are going to apply the Hess law. So, but we are not going to use formula method because not all the thermochemical equations given here are enthalpy of formation. Only equation 2 and equation 3 are considered as enthalpy of formation. We only can use formula method when all the thermochemical equations given are enthalpy of formation. Because C2H6, CO2 and H2O are not elements, so that's why they are not considered as enthalpy of formation. So if like that, then we are going to use algebraic method. So if we want to use the algebraic method, means that we need to know the target equation. So for this question, they didn't let us know the target equation, but they asked us to calculate enthalpy of formation of ethane. So if you're able to write the target equation correctly, basically you will get 1 mark here. Then we always start with the target equation, which is 2 mole of carbon. So 2 mole of carbon is in equation 2. So you can maintain equation 2, you will get another 1 mark. Next, we have the hydrogen gas, but this hydrogen gas appear twice in the above equation, which at equation 1 and equation 3. So if this is the case happen, normally we will ignore hydrogen gas first and we proceed to C2H6. So for C2H6, we notice that this is the product and then here is the reactant. So we are going to reverse equation 1. So once we reverse the equation 1, we get this chemical equation. Then here already have 1 mole of hydrogen gas and then we need another 2 more. So that's why equation 3 need to times 2. Due to equation 3 needs to times 2, the value over here supposedly will become kilojoule, 571.6 kilojoule, but not kilojoule per mole. Okay, then we want to cancel out the carbon dioxide and water, so we're going to maintain the equation 4. So and then press the calculator, you will get the value negative 85.1 kilojoule per mole. So due to the student won't get marked for this one because the unit in the equation is wrong. So for this question, the student will able to still get the marks 5/5. Okay, now let's continue with question 2b. An amount of 1.5 gram of glucose is burned in bond calorimeter. So when we read the question up to here, so we understand that this question is related with the enthalpy of combustion. So if the question related with enthalpy of combustion, so basically we will have 3 steps. First, maybe we need to find out the number of mole. Second, we need to determine the Q value, heat of reaction. And the third one, we need to heat of combustion or heat of neutralization. So when you are given the mass, so means that you are able to determine number of mole. So for this answer, mole of glucose 8.33, exponent negative 3, 1 mark. Then next we continue reading. The calorimeter contains 2 kg of water and the temperature is 22.5 degrees Celsius to 24.8 degrees Celsius. So from here we know the change of temperature and this is the mass of water. So we understand that this value will be used in MC delta T. So we can see here the heat released by combustion equal to heat absorbed by water, which is MC delta T, 1 mark. So we press all the answer press all the value into the substitution. So if you notice over here they give us degrees Celsius, but here they give us the Kelvin. Basically the Kelvin and the degrees Celsius is in terms of the value we can consider similar in terms of the change of the temperature. So press the calculator, you will get the answer 19.228 kilojoule. So next, the question is asked us to determine heat combustion of glucose in kilojoule per mole. Means that we need to do the comparison. So after you compare, then you will get 2307.37 kilojoule per mole. So this is the working step, but basically actually it's better we put the negative sign at this comparison here. Then you have to rewrite again. Heat of combustion means that the symbol is delta H. C combustion is negative 2307.37 kilojoule per mole. So this question you will get 5 marks. Question number 3. So the question given us the cell notation. As we know, cell notation is as simple as ABC. So A is stand for anode. Anode undergo oxidation. And if we write the equation, half equation, it is lost electron. So silver ion will undergo reduction. So basically this half equation is correct, even though we cannot see it clearly here. I know it's correct because of the overall equation is correct. So 1 mark for the overall equation, and then for the Nernst equation 1 mark. And then when you press the calculator, I think the answer is not positive 0.93, but it's positive 0.875 mole due to this one. So this value 0.875 supposedly 1 mark, and then the question asks us determine whether it is spontaneous or no. So you mention spontaneous, so with the reason E cell more than 0. Okay, so for this question, the student cannot get the marks for the spontaneous because there is no explanation. So normally, if the question with the terms determine, means that you need to give the reason. Okay, question 2. State the effect of decreasing concentration of SN2+. Okay, correct. So when the concentration SN2+ decrease, the ratio concentration also decrease. This basically will make the log Q decrease as well. And if based on here, if this whole value is decreasing, then E0 cell remain unchanged. So the E cell supposedly is increased. So this question, the student get 1 mark here for the overall equation, 1 mark for the Nernst equation, 2 marks only for this question. Okay, let's continue with question 3b, an aqueous solution NaI. So when we see aqueous solution NaI, so we know the species in the solution is Na+, I-, and also H2O. It's electrolyte for 3.5 minutes using platinum electrode. Platinum electrode is inert electrode. Calculate amount of current flow. That means you need to determine the ampere if 135 ml of oxygen gas is collected at STP. So, and then we know the molar volume at STP is 22.4 liter per mole. So when we read this question, we have already an idea this is related with the electrolytic cell, and basically it will involve 4 steps. So first we may calculate Q equal to IT. We need to write the half equation, we need to compare, and we need to determine number of mole. So based on this question, we have the volume and also molar volume. So means that I can determine the number of mole. So the student already calculate the number of mole of oxygen. So if possible, please keep the value in 4 significant figure. Okay, after we get the number of mole, then I think next we are going to do the half equation before we can do the comparison. So in this question, because they mentioned that oxygen gas is produced, so when oxygen gas is produced, basically it is produced from water and it's happen at the anode. So that's why we will get the half mark for the we will get the marks for the half equation at the anode, but this half equation won't let you have the full, will not be given the marks due to the H+ doesn't have the physical state. Okay, next we are going to do the comparison. So this is the comparison, so another 1 mark, and then we use Q equal to IT to get the value. Ampere is 11.03 ampere, so here is another 1 mark. So for this question, you will get 3/3 marks. Okay, we already finished discuss 3 questions of physical chemistry. So stay tuned for the next video, which we will discuss the organic chemistry questions. See you in next video. Bye.